Hello, everyone. This is Amir McKean, electrical engineer, author, publisher, and founder of AIC Publications and the Black Stemporium podcast, your number one source for science, technology, engineering, and math, starting your own publishing business, building generational wealth, economic empowerment, all centered around the Black African American experience. Today, we're going to be talking about the force of electricity. Without any further ado, let's get started. In answering the question, where does electricity come from? We must first understand that electricity or the flow of electrons is a result of a specific event happening at the atomic level. We start with asking four basic questions. One, what is an electron? Two, when does an electron move? Three, where does it go when it moves? And four, what happens when an electron moves? Dealing with the first question, what is an electron? An electron is the third of a three-piece atomic structure. The atom, which is the smallest particle into which an element can be divided. An atom has three parts: a proton, which is a positive charge, a neutron, which has no charge, and the electron, which is negatively charged. The body of the atom is called the nucleus, and that holds the protons, while the electrons actually orbit around the nucleus. One of the laws in physics is that opposite charges attract and like or same charges repel. As an electron, as you can see with the graph in front of you, orbits or circulates on the outer shell of the nucleus. Because there is an attraction between opposing charges, i.e., opposites attract, of the protons and the electrons, and a repelling of like or same charges, i.e., protons are repelled by other protons, electrons are repelled by other electrons. There is a natural force that exists that's causing this behavior. It's this force that keeps the electrons orbiting around the nucleus. This force is called the electrostatic force. In the lesson, Where Does Electricity Come From tutorial, I explained the purpose of the math, which is to bridge the gap between the science, the technology, and the engineering. And here we get to see an example when it comes to the electrostatic force. There is actually a way to calculate this force so that we don't have to always speak about it in the abstract. The way this force is actually calculated is with a simple formula called Coulomb's law, which is what you're seeing in front of you now. This Coulomb's law, or the electrostatic force equation, this merely explains that the electrostatic force generated on two charges that you're seeing in front of you is directly proportional to the values of both charges, Q1, Q2. And the K value, which is that 9 times 10 to the ninth power number that you're seeing, that's a standard number to represent the base amount of force over a distance, and the electrostatic force is inversely proportional to the distance between the two charges. Simply put, we merely multiply the K value with the charge, which can be a proton, a neutron, or an electron, which means the numbers can either be negative or positive. Then we take that and we divide that product by a distance between the particles that we've squared. Coulomb's law also helps us to calculate electromagnetic fields. The smallest value on any one charge is a really small number. It's 1.6 times 10 to the minus 19th coulombs. So here, once we go through all of that, we get the following truths in terms of formulas. 1 ampere of electric current is equal to 1 coulomb moving every second. 1 ampere of electric current is equal to 6.625 billion electrons moving in 1 second. Or that is to say, also, almost 400 billion electrons will be moving in 1 minute, or 2,385 billion electrons are going to move in 1 hour, equivalent to 1 amp. Now, looking at Coulomb's law, we can pretty much tell that if we're dealing with numbers raised to the ninth power, as that K value is, just on 2 charges alone, you can imagine how great in value the numbers will be when we're discussing electromagnetic fields. Here, what the math is telling us is that the electric force and the electromagnetic field will be huge, truly huge. In the Where Does Electricity Come From tutorial, we provided a new definition of STEM that we can actually apply here. See, because the electromagnetic fields are used in X-ray machines, they're used in MRI machines, which are used to diagnose different medical conditions. They're used in automotive applications. They're used in computers, used in amusement park rides. And we'll use them too when we create circuits to demonstrate how these applications also work and are related. Why this electrostatic force exists in the first place is simply because it always has. Now, the next question that we have to answer is, when does an electron move? The event that we spoke of earlier that disturbs the electrostatic force, keeping the electrons orbiting, is when the electrons break out of orbit and become what is called free electrons. Since there is an electrostatic force keeping them in orbit, there is also a force that can occur that can cause the electrons to move. There are some elements that have electrons that are easier to move than others. These are actually listed on the periodic table that you see in front of you. Now, the group number on these periodic tables, it indicates how many electrons are in the outer shell, the outside shell of the atom. Those with the fewer outer shell electrons, those are easy to free up an electron. Those that are easy to free an electron are called conductors. So those in group 1 that you saw in the periodic table, those are good conductors. Good conductors such as copper, gold, silver, those elements that have 8 electrons in their outer shell, they are assigned to group 8. And they find it very, very, very difficult to give up their electrons. And those are called insulators. So those in group 8, which are also insulators, are iron, cobalt, and a few others. Those that are in the middle of the periodic table are in group 4, and they're called semiconductors. They're called semiconductors because they have 4 electrons in their outer shell. And it's not necessarily easy for them to free an electron, but it's not that hard. It's not as hard as those in group 8 either. So silicon and germanium, they are 2 semiconductors that are used very widely in electronics and in engineering for that particular reason. Now, in addition to those elements that can produce free electrons, the out of orbit movement of electrons also occurs when the different conditions happen. A, there's heat that is applied to the atom, or the atom is subjected to light, or you have an electric disturbance, or you'll have an applied force. An applied force can be created by applying various engineering sciences that produce those forces. See, in the Black Stimporium and the 10-minute engineering program of AIC Publications, we can create multiple electrical disturbances and electrical fields through designing different circuits. These circuits that we're going to be designing, they've been used for decades, but are literally the backbone of a great deal of technology that we're still seeing produced today. If you've enjoyed our content and want more of it, I need you to do 3 things to help us reach more of our audience. First, go to our website using the link you see on your screen and subscribe to the AIC Publications newsletter. You do this, you'll get weekly emails whenever we release tutorials, podcast episodes, new books. You'll be able to compete for contest giveaways and more. If you do this, you'll also be able to receive a free book. This is very important because we're trying to develop our own community independent of the different mediums and platforms of social media that are out there. If those go away tomorrow, we want to be able to reach out to you today and continue this community that we're building. Second thing that you can do, subscribe to us on the current platform that you're seeing this on, that you're watching or listening to me right now. The third, share our content with 3 of your friends using the hashtag AIC Publications and give us a link. Thanks in advance for helping us to demystify the math and simplify the science. Remember, here we want all of our community members to attain the knowledge, innovate for success, command your future. Till next time, we wish you all the best. Peace.